Good evening, students. Welcome to Chemistry Online Plus. In the previous week, we are discussing about Lewis structure for the covalent species. So, wherein that the molecules, even the positively charged species, we discuss it. I will continue regarding the Lewis structure for even negatively charged species. In that, first one I will take NO2 minus. This is known as nitrite ion. See the suffix here, ITE is there, ITE, nitrite ion. Now, what are the steps that are followed while writing the Lewis structure where for this species are given any covalent species? First step is you have to calculate the total number of valency cell electrons. After that, you have to see the charge. If it is a negative charge, you have to add. That negative charge is to be treated as an electron. That one you have to remember, an electron. Suppose if it is a positive charge, you have to subtract. Okay. Now I will take the number of valency electrons, total number of valency electrons. For the nitrogen atom, one nitrogen atom, 1 into 5 plus 2 into 6. Now it is gaining an electron, therefore add plus 1. This is 5 plus 6, 2 are 12 plus 1. If you are adding total number of electron, valence cell electrons, 18 will be there for this nitrite ion. That one you have to remember. So after knowing the first step, we have to go for the next one. What is that one? We have to arrange these electrons in such a way that each atom acquire 8 electronic configuration. That one you already came to know. One is nitrogen atom, another one is oxygen. So you have to remember your central atom is, which is a less electronegative one, which is a larger weight in size, and it is always having less number of atoms. That one you have to keep in your mind while selecting the central atom. Now here I will take nitrogen atom as a central. Now here 2 oxygen atoms are there. Let us see first. What do you have to do first? So show it single bond. Now out of 18, 4 electrons are involved in the bonding. Suppose if you are representing which one remaining electrons like this as a lone pair. Let us see first lone pair. Okay. Now 1, 2 pair, 3, 4, 5, 6. 6 2s are 12 over. Now let us see here. Where in this case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now question arises, when this atom is already acquired 8 configuration, this oxygen atom 2 also. What about this nitrogen atom? No. Now what you are going to do in this case? These lone pair electrons that are utilized, which purpose? To form a double bond. That means now I am, see here, removing. Now I am showing double bond. Now net charge is -1. You write as it is. Let us see the structure. 1, 2, 3, 4, 5, 6, 7, 8. Okay, no doubt. 1, 2, 3, 4, 5, 6, 7, 8. And it is also acquired. Like this we are representing. Even we may write the same species in this way also. What is that one? Or we can write oxygen. Let us see here. Now I will take nitrogen atom. Here I will show a double bond. Now again net charge -1. Let us see here, 6 plus 2, 8. So 2 plus 2, 4. Again, 4 plus 4, 8. Now this is also 8. Like this, we can write the Lewis structure where for nitrite ion. Coming to the next one is, in the same way, I will take one more, which is that one. Nitrate ion I will take. ITE over now ATE we will go for. Nitrate ion. How to write the Lewis structure where for nitrate ion? NO3 minus nitrate ion. Nitrate ion. Suffix you have to see. ATE. Here to also first step, total number of valence shell electrons 1 into 5 plus 3 into 6. Again it is gaining, add plus 1. Now 5 plus 6 3s are 18 electrons plus 1. If you are adding all these, it will be 24 electrons. 24 electrons. Now how to arrange all these? Again you came to know here central atom is nitrogen atom. I will take, let us see here. Nitrogen atom I will write. Now how many? So 1, 2, I will take here also, no problem. 3 oxygen atoms I wrote. Now if you are forming a first single bond. Yes. Now what happens? 6 electrons we utilized where in the bond formation. Now here I am showing only 2 lone pair and making a double bond. Then what about this? 1 pair, 2 pair, 3 pair, including this one 8. In the same way, you can write on this oxygen atom also. Now let us see first. We will try. Net charge is -1. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So total number of electrons, so many? 24 electrons. What I wrote? So between this oxygen atom and nitrogen, there is a double bond. Whether nitrogen atom is satisfying its octet configuration? Yes. 1, 2, 3, 4, 5, 6, 7, 8. Like this, you have to arrange all these electrons in such a way that each atom acquire octet configuration. Okay. Now coming to the, even we can change, that one you will be knowing. Here you can show a double bond, again single, single. Here also double, remaining single, we can write. Now coming to the carbonate radical. What is the Lewis structure for that carbonate radical? The third one, CO3 2 minus ion, carbonate ion. Carbonate ion. Radical, negatively charged species. Here also the first step is valence shell electrons. Where in the carbon? 4 plus 3 into 6. Now it is gaining how many? 2 electrons. 4 plus 6 3s are 18 plus 2. Again it will become 24 electrons, student. 24 electrons. So here less electronegative, less number of atoms, that is carbon, you have to take as a central atom. Number of oxygen atoms, again how many are there? Now 1, 2, here I will take 3. Now here, if you are showing a first single bond, let us see, single bond. Now, so out of 24, how many? 6 electrons I wrote, remaining 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let us see here, 2 more I will add. Whether first 24 electrons are there or not. Here I wrote 6, 6, 6. Totally 6 3s are 18. Now here 20, 22, 24. But what about this carbon atom? Okay, we have been shown the octet configuration for the 3 oxygen atom. What about the carbon atom? So whatever the lone pair electrons will be there, that one is utilized again to form a multiple bond. Now I am showing here a double bond. Now, if you are showing a double bond, 1, 2, 3, 4, 5, 6, 7, 8, carbon also acquire octet configuration. Now you are representing in this way. Net charge is what? 2 minus, you want to write. So without failure. So here even we can show the double bond between this carbon and oxygen. This oxygen and carbon atom. Here also, then it will become single. So this is what you call now available number of the valence shell electrons are arranged in such a way that each atom acquire nearest noble gas configuration. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So available number of valence shell electrons for carbon 4, oxygen 6 into 3, 3 atoms of oxygen are there, 18 plus 2, you have to add 24 electrons. Like this we will write. Now very important thing is, what is that one means? See here, if you are going to consider any polyatomic ions, not only the polyatomic ions, even polyatomic molecule. So whatever the net charge will be there, no, that net charge belongs to that whole ion. That charge does not belong to any particular atom. What is that one? Let us see one of the interesting, very important concept, that is formal charge, student. In your theory also, in your competitive exam. What I said for you, in a polyatomic ions, the net charge possessed by that ion as a whole you have to consider. For example, if I am taking CO3 2 minus, this net charge 2 minus, it belongs to a whole where for this polyatomic ion. This net charge does not belong to any particular atom, that one you have to remember. Then what it means now? So it is possible even to assign individual formal charge on each atom. Individual formal charge on each atom. Where? In a polyatomic ion or in a polyatomic molecule, that one you have to remember. Then what is this formal charge? How that one is calculated? What is the formula that one we are using? So this is one of the important bit. Now coming to the definition, what it says? The difference between the number of valency electrons of that atom in the isolated or a free state. I am taking a particular atom, I am assigning the formal charge on that atom. Then how it is to be defined? The differences between the number of valency electrons of that atom in an isolated or a free state to the number of electrons that are assigned to that atom where in the Lewis structure, that is known as formal charge, that one you have to remember. Now I will read the definition of this formal charge. The difference between the number of even we can get total number of valency electrons, total number of valency electrons of that atom in an isolated or free state, and the number of electrons assigned to that atom in a Lewis structure. So what I said, the difference between the total number of valency electrons of that atom or valency electrons of that atom in an isolated or a free state, we can say, and the number of electrons assigned to that atom in a Lewis structure, that is known as formal charge. So total number of valency electrons, or even you can say the difference between the number of valency electrons of that atom in an isolated or a free state, and the number of electrons assigned to that atom in a Lewis structure, that one you have to remember. Okay. Now coming to the formula. What is that one? So instead of this, if you are knowing the formula, even you can easily calculate the formal charge on each atom. What is that formula? So first I will write in statement, then we will go for formula. What is that one? Formal charge on an atom in a Lewis structure that is equal to, formal charge on an atom in a Lewis structure is equal to total number of valency electrons in the free state. When I took total number of valency electrons in the free state minus total number of non-bonding electrons. These are to be known as, you know already, lone pair we can say. In that again, minus of 1 by 2. Again here I am writing total number of bonding electrons, bonding electrons. Within the bracket I will write bond pair, shared pair electrons also we can say, shared pair. So very simple in the verbal statement, total number of valency electrons in the free state minus total number of non-bonding electrons, these are to be known as a lone pair, minus 1 by 2 total number of bonding electrons known as a shared pair electrons we can say. Instead of this, even we can do the same thing. What is that one? Formal charge is equal to total number of valency electrons. I will write V. V stands for not victory here. Valency electrons in the free state. Minus total number of non-bonding electrons. Plural form also to see. Electrons. That one I will write as V minus L. Minus 1 divided by 2 into, I am writing S. S is nothing but the shared pair electrons, bonded pair electrons. But here I took total number of bonding electrons. You have to count all the electrons. Therefore, what is your formula? Formal charge on an atom in a Lewis structure is equal to V minus L minus 1 by 2 into S. V stands for valency shell electrons. L, lone pair of electrons. 1 by 2 into the shared pair electrons. That one you have to remember this one. Let us take few examples. You will be knowing more easily how to calculate the formal charge where on each atom. So that may be where from a given polyatomic ion or a polyatomic molecule also. Dear students, you already came to know which is that word, ozone molecule, O3. Assign the formal charge on each oxygen atom. For that, what is required? Two things. First one is the Lewis structure. Second one is this formula. This formula and Lewis structure, if you know 100%, you will calculate. This is for 3 marks in your theory exam. Let us see first ozone molecule. First step already you came to know. 3 into valency shell electrons. Where for oxygen? 6 threes are 18 electrons are there. Now I will write here the structure first. 1, 2, 3. Now here if I am showing a double bond, here single bond, let us see here. Now here 2 electrons, 1 pair. Here how many now? 1, 2, 3, 4, 5, 6, 7, 8. Overheads now. Where for this one I am taking here how many? 2. Now for this one I am writing how many? 3 pair electrons. Better this one we will write now in this way. Okay, 2 lone pair. Now this is the Lewis structure where for ozone molecule. Let us see first. 1, 2, 3, 4, 5, 6, 7, 8. Take over. 1, 2, 3, 4, 5, 6, 7, 8. Over. So 1, 2, 3. 2, 3 is 6 plus 2. 8. Over. Now I will differentiate these 3 oxygen atoms. This is oxygen atom, 1 student. This is 2. This is 3. This is 3. Now I am calculating formal charge. Formal charge. Charge on oxygen 1. You may get confusion here. Oxygen 1 atom. That wise, better we can write like this also. Oxygen 1 atom. Oxygen 1 atom. Because all the same atoms, no. First you have to differentiate. 1, 2, 3, you have to give the number. Now what is that formula? Again I will write V minus L minus 1 by 2 into S student. What about V? Valency shell electrons. For oxygen atom, 6 lone pair, non-bonding electrons. Total number of non-bonding 1, 2. I will write student. Now if I am writing 2 here, 2 lone pair, 1, 2. Total number of non-bonding electrons 2 minus 1 by 2 student. What about S value here? Shared pair, bonded pair. 1, 2, 3, 4, 5, 6 student. I will write here 6. Now this is equal to 6 minus 2. 2 1s are 2 3s are. That is minus 3. 6 minus 5. This is equal to plus 1. Plus 1. Plus 1. So student, I think so you are not seeing properly. You are not seeing this properly. So 6 minus 2 minus 3. Shall I write here only? No? I think so you are not seeing properly. That is 6 minus 5. This is equal to plus 1. Plus 1. Okay. So this is the problem. No? Board is very small. So now I will write how much now for this? Oxygen 1 plus 1 charge. I will write. Now I will go for second, which is that one. So formal charge, okay. Already you came to know on O2, formal charge on O2 I will write. On oxygen 2 atom, okay. Now this is equal to, we can write formula V minus L minus 1 by 2 into S. This is the second. Better I will write in word also. Most of the students may get confused. Formal charge on oxygen atom 2. Number I gave already 2. That is 2. Oxygen atom 2. So V minus L minus 1 by 2 S. V again 6. For this one it is 6. Minus lone pair of electrons 1, 2, 3, 4. 1 by 2. What about the shared bonded pair of electrons? 4. 2 1s are 2 2s are. This is 6 minus 4 minus 2 equal to 0. Now what we came to know from this? So formal charge on second oxygen atom. So this one is second. So what we come across means whose formal charge is, here I am writing 0, 0. Okay, now you can take 0. Coming to the formal charge on oxygen 3, third oxygen atom 3. Okay, that is again V minus valency shell electrons, everybody you know, for oxygen 6 minus lone pair of electrons 1, 2, 3, 4, 5, 6 are there, student, minus 1 by 2, the said pair of electrons 1, 2. Now 6 minus 6, 2 ones are, that is equal to minus 1. 6 minus 7, that is equal to minus 1. Okay, now we can write better. If you are not seeing minus 1, so this is minus 1 plus 1, this is 0. 0 we can write. Now let us see here. What we come across means we assigned individual charge, formal charge on each atom where in a polyatomic molecule like ozone. There is a simple method is there. This is for theory paper. If you are writing like this, systematically you have to write all these things. But where for your competitive exam, what you have to do? This formula now we will verify whether is it holds good or not, which is that one. So shortcut formula method I will give you. What is that one? You know formal charge that is equal to number of, don't say it is no, number of electrons brought minus number of electrons have. First, if you are perfect, then you can verify. How? No, number of electrons brought minus number of electrons have. This is also only for competitive exam, just you have to recall this formula. Now see here, this is the oxygen 1 atom. Number of electrons brought how many? Everybody you know? 6 we brought. Valence shell electron 6. Number of electrons have this one. So how much? See here, 1, 2, 3, 1, 1 each. Number of electrons have this one. 1, 2 from this atom. This is also okay. 1, 2, 3, 4, 5. Then plus 1. That is plus 1. Even we can go for which one? The oxygen atom 2. In this case, what is that one? Now, fast. If you are very fast, while so taking so many examples, you will be knowing very easily. That is 6 again. Number of electrons brought 6. And number of electrons have this oxygen second atom, oxygen 2. So how many? So if you are going to consider, see there, 1, 2, 3, 4, 5, 6. 6 minus 6, 0 student, 0. This is for 2. This is for 1. One more for this one. I will take here. What is that one again? So as usual, number of electrons brought how many? 6. Number of electrons have, see here, 1, 2, 3, 4, 5, 6, 7. Then it is equal to minus 1. Like this also, there is a formula you can go through, but it is only where for your competitive exams. If you study, you will write V minus L minus 1 divided by into S. That is valency electrons minus lone pair of electrons minus 1 by 2 into bonded pair, said pair electrons, we can say. Okay. Now I will take one more example. So first one is polyatomic molecule. So polyatomic ion I will take. Ion. Which one? Better. Already we discussed the Lewis structure, where for the carbonate radical. That one also we will go through. CO3 2 minus student. Carbonate radical. And first step is you have to write the Lewis structure for this radical given this polyatomic ion. Okay, so as usual you came to know that 4 plus 6 into 3 plus 2, that is 24 electrons are there. Now I will write the Lewis structure first. What is that one? Let us see here. Central atom is carbon. Now oxygen atom. Just I wrote 3. Okay. Here I am showing first single bond. So no octet configuration. That is going to be double. Now remaining lone pair. Let us see here. Okay. Now for this, yes, for this one, whether 24 electrons are there or not, that one you have to see. 2 minus I. Now I am assigning the formal charge on each oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. Okay, no problem. This is also 8. 1, 2, 3, 4, 5, 6, 7, 8. What about this one? Okay. Now if I want to take, so 6, so plus 2, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24 are there. No doubt. Now very interesting thing is, again there are 3 oxygen atoms. You number them. You number. This is 1, this is 2, this is 3. Now what I will do means, first carbon I will find out. Formal charge. Only one time I will read the formula, you have to recall. Formal charge on carbon atom. On carbon atom. No numbering, only one. So what is that formula? Here I will write formal charge equal to V minus L minus 1 by 2 into S student. Now if you are going to consider where for this carbon atom is there. So V stands for formal charge on carbon atom. V stands for valency cell electrons. Valency electrons. How many? Everybody you know? 4. Lone pair of electrons. Is there any lone pair of electrons? No. 0. 1 by 2 into shared pair of electrons. Bonded pair or shared pair. 1, 2, 3, 4, 5, 6, 7, 8. Into 8. 2 ones are, 2 fours are. 4 minus 4, that is equal to 0. So right here, 0. 0. Where for this carbon? Now I will go for formal charge. Formal charge on oxygen 1 atom. Number I given, that was I'm taking 1 atom. This one I given 1. Now again, valency cell electrons. Where for the oxygen? 6 minus lone pair. 1, 2, 3, 4, 5, 6. Minus 1 by 2. Shared pair of electrons. 1 and 2. So 2 ones are. 6 minus 6 minus 1. 6 minus 7. That is equal to minus 1. That is equal to minus 1. Now I will write minus 1. Okay. Now coming to the next one is I will see here. I will write here, because if I am writing down means you can't see. It's not visible. Is it correct now? Now I will go for next one. What is that one? See here. 2 I am taking. Second oxygen atom. Formal charge on oxygen. What is that one? 2. Oxygen 2. Now again formula. 6 valency electrons. 1, 2, 3, 4. So lone pair. Again 6 minus 1 by 2 into 2. That is 6 minus 6 minus 1. 6 minus 7. That is minus 1. Where on the oxygen 2? This is minus 1 I am writing. Now, if you are going to take, where for this? See here. Formal charge. Dear students, here, formal charge on oxygen 3. Third atom. Now, in this case, so again, as usual, 6 valency cell electrons, 6 are there. Lone pair of electrons, 1, 2, 3, 4. 4 minus 1 by 2. So now we have 1, 2, 3, 4. Okay. So now let us see here, where for this one? 1, 2, 3, 4, 5, 6, 7, 8. What I wrote now? 6 valency cell electrons. Now minus 4, that is lone pair of electrons. 1 by 2 into 4. 6 minus 4, 2 ones are, 2 twos are, minus 2. 6 minus 6, that is 0. Wherefore this I will write 0. So here minus 1, this is again 0. Like this, you can find out the formal charge on each atom. Now coming to the next one, what is that one? Let us see here. So you know minus 2, if you are writing now, removing this minus 2 means this is minus 1, this atom is minus 1, this is 0, this is 0. What we done? We assigned the formal charge on each atom wherein this Lewis structure. This is minus 6, minus 1, minus 7. Subtract, you will get how much? Minus 1 for oxygen 192. Now we will go for the one more example. After that, I will discuss limitations of octet rule. Okay, what is that one? Let us see here. One more polyatomic molecule I will take. Which is that one? Pozin gas, you know, all of you. Pozin gas. So the formula is COCl2. COCl2. When carbon monoxide reacts with a chlorine gas, then the formation of a pozin gas that will take place. Now, how you are assigning the formal charge on each atom? Where from this pozin gas? Here, pozin gas, if you are going to take this, first you write the Lewis structure for that. Now, carbon is there. Valence electrons 4. One oxygen atom. Valence electrons, how many now for oxygen? 6. 2 into chlorine, 7 are there. 4 plus 6, 7 twos are, that is 40. Again, add student, you will get 24 electrons. Now, here very interesting thing is, which is the central atom? Best example again to say that one, which is the central atom? COCl2, carbonyl chloride, are commonly known as a pozin gas, poisonous gas. Now, here I am taking the central atom is carbon. Here, chlorine atom I will write. Here also chlorine atom I will write. Here, oxygen atom I will write. First, see here, single bond, single bond, single bond. If you are showing a double bond between the carbon and oxygen atom, left out a number of electrons. Better I will write in this way. What is that one? See, student. Okay. Now 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. What about this? Now, what about this one? Why I took this one? It is asked. See here. 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Whether the 24 electrons are there or not. Here I got 6 plus 2, 8. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 electrons are there. Now again, there is a problem because 2 chlorine atoms are there. Only you have to give number 1, number 2. Oh. Now first I will go through. So to write the formal charge on each atom where from the pozin gas. Pozin gas. Now let us see here. First one. So what is that one? Formal charge. Formal charge on oxygen atom. Oxygen atom. Only one is there, no numbering. Again, formula. Formal charge equal to V minus L minus 1 by 2 into S. Okay. Now, so what is that one? V. Valence shell electrons for oxygen atom. How many now? It is 6. Minus. Dear students, lone pair of electrons. 1, 2, 3, 4. Now 4. Minus 1 by 2. What about the shared pair? Bonded pair. It is 4 student. 6 minus 4 minus, that is 2 ones are 2 twos are. That is 6 minus 6, 0. What we came to know? 0. Okay. What about this chlorine atom we will take? Formal charge. Formal charge on chlorine atom 1. Chlorine atom 1. Chlorine 1 atom. Okay. So chlorine atom 1. Just you have to make INE. So here also, what is the formula directly? Valence shell electrons 7 minus. Let us see the lone pair of electrons 1, 2, 3, 4, 5, 6. Total number of non-bonding electrons to it 1, 2, 3, 4, 5, 6. I wrote 6 minus 1 by 2. Here let us see here 1 by 2. So total number of bonding electrons 1, 2. Now 2 I wrote. Again 2 ones are 2. 7 minus 6 minus 1. This is equal to 7 minus 7 equal to 0. Therefore this also 0. Now you can easily predict where on the chlorine atom 2 also, because number of, see there, bond environment is same. Here also how many? So you can see here 6 lone pair of electrons. So 2 electrons are the bonded and valence shell electrons also same. Therefore, if you are writing, so where on the formal charge on chlorine atom 2. So chlorine 2. So wherefore this again as usual valence shell electrons 7 minus lone pair of electrons 6. 1 by 2 into again 2. So 7 minus 6 minus 2 ones are minus 1. 7 minus 7 it is equal to 0. What we come across? 0 for this one also. What about this carbon atom? So formal charge on carbon, only one atom, no numbering. Again 4 minus, no lone pair of electrons. Let us see whether any lone pair. No, all are involved. 0. 1 by 2. The total number of bonding electrons 1, 2, 3, 4, 5, 6, 7, 8. 2 ones are 2 fours are 2 fours are. That is 4 minus 4 equal to 0. See here what we come across where from this positive gas means the formal charge on each atom, that is 0. That one you have to remember. Now coming to the last bit in that I will complete, very important, which is that one. So what about this limitations of octet rule, students? Limitations of octet rule. Let us see this one. Pick. So 1 or 2 are there. Just I will explain. Limitations of octet rule. Limitations of octet rule. Yes. Again, you may have some doubt. So though it is useful, which one? Octet rule. But it is not a universal. Don't generalize. It is the ultimate rule. Where for the stability of a molecule, covalent molecule, no. So it is not a universal. First one, where we can see. So a few examples I will take. First one, hydrogen molecule. Hydrogen molecule. Hydrogen molecule. So all of you already came to know between the two hydrogen atom. Between the two hydrogen atom, how many know? 1 electron pair. So both the hydrogen atoms are acquiring nearest helium. Helium configuration. Helium means 1s2 configuration. But we have taken octet, even though this molecule is stable. Okay. Second one is incomplete. Incomplete. Even we can say which type? Octet of the central atom. Which are the examples in this case? We can see. First simple example, lithium chloride you take. So between lithium and chlorine, only 1 electron pair. Because you know that. So here also, if you are going to see, so lithium atom, incomplete octet of the central atom. So lithium is the, if I would take central atom, chlorine is bonded. Lithium here, only see here. How many? 2 electrons we can see here. 2 electrons. So that is what we come across. If I want to take here also, lone pair of electrons are there. Let it be 1 true. So how many? 4 are there. So incomplete octet we can take. Leave about this one. Even we can take, which is that one. Best example. Beryllium hydride. So central atom beryllium I will take, hydrogen, hydrogen. Correct? Now here around the central atom, how many now? 4 electrons are there here also. So incomplete octet, even this molecule is more stable. Now let us go for next one, which is that one. Boron trifluoride I will take. Boron trifluoride, which is the central atom, where in this case boron. Now I will take fluorine atom, fluorine atom, fluorine atom. Around the central atom, how many? Only 6 electrons are there. Incomplete octet. Such type of a molecules, they are more stable, even they are not satisfying octet configuration. These types of molecules are known as electron deficient. Electron deficient molecule. Electron deficient molecule. Is it correct now? Even we can go so many examples where in this case, which are these? Like we can write boron trifluoride also. So incomplete octet we can observe. Next to one more is, what is that? So third limitations we can see, which is that one. Let us see here first. That is extended, we can say, or the expanded octet of the central atom. Expanded octet of the central atom. So here I will take one of the 2 examples. Already you came to know, which is that one means phosphorus pentachloride you take, sulfur hexachloride. Let us see here, central atom is phosphorus. Now, so bonding even we can write. Later you will be knowing all these, but let us see here. Okay. So what we come across in this case? So if you are joining like this, so better I will write all these in this way only. Let us take the central phosphorus atom. Chlorine, PCl 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So central atom is 10 electrons. Sulfur hexafluoride, if you are going to consider sulfur. Now, fluorine atom. Now, above 1, we can write like this. Now here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many? 12 electrons are there around the sulfur atom. Just you have to take now. So 1, 2, 3, 4. So 5, 6 valence shell electrons. So each are sharing with the 6 electrons of sulfur. So each fluorine atom require 1, 1. So wherefore their octet. But central atom, if you are going to see, so beyond expanded we can see 12 electrons are there. Still this molecule is more stable. Even if you are going to take, which is that one, sulfuric acid student, H2SO4. H2SO4, which is that one in this case, H2SO4. So I will write the structure where for this central atom is sulfur. If you are showing a double bond, okay. Now here oxygen, hydrogen. I can write here lone pair of electrons. Like this you write. Now after forming a bond, still we can see. Now this is oxygen, 2 lone pair of electrons. This is hydrogen atom. Okay. Now 1, 2, 3, 4, 5, 6, 7, 8. No problem. Therefore the remaining. This is helium. This is nearest noble gas. What about the sulfur atom? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 electrons are there. Such types of molecules are known as hypervalent compounds. Hypervalent compounds. Expanded we can say. Still these molecules are more stable. Now coming to the last one, which is that one. Odd electron molecule also we can take. They are also more stable. Which are all these? Odd electron molecule. Odd electron molecule. See, where in this odd electron molecule, I will take only two examples. Which are these? One is nitric oxide. Nitric oxide. Another one is nitrogen dioxide. Nitrogen dioxide. Let us see here, if you are going to see regarding this nitrogen atom. Now, so if you are taking oxygen atom, so showing a what you call double bond. Now, lone pair of electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now here, I will get one more. Let us see first, what about the total number of valence shell electrons? That is, where for the nitrogen 5 plus oxygen 6. 5 plus 6, 11 electrons are there, student. 11 electrons, that will you have to remember. Now, if you are representing 1, 2, 3, 4, 5, 6, 7, this is odd electron. Odd electrons are there on nitrogen, still nitric oxide is more stable. Now, coming to this one, again you can add 5 plus 2 into 6, 5 plus 6 to 12, 12 plus 5, that is equal to, so add 17 electrons. Let us see the structure. Nitrogen, oxygen, oxygen, I will write. Now here if you are representing this molecule, what we come across? Here you have to show a double bond, single bond, one electron you are representing. Let us see first, 1, 2, 3, 4. What about this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 electrons. What we come across on the nitrogen atoms here? 1, 2, 3, 4, 5, 6, 7. 7 odd electrons will be there. Therefore, here also you can see even some charge that will be written on the nitrogen atom. Why? That one I will tell you after explaining the coordinate bond. So, what we come across where from these? So these molecules are also stable. That means it is not inversal, which one octet group. Apart from that, few more limitations are there. Which are these? Pick. Now I will explain one by one, and I will stop at this stage. Which are these? One is the what we come across means this octet rule is based on the chemical inertness of noble gas element. Means there is no reaction at all. We already said chemical inertness, but we know the noble gas elements such as you take krypton, xenon. Even these elements they combine with. Which are these more electronegative elements like oxygen and fluorine to form a noble gas compounds. Many more number of noble gas compounds. Which are these? So among that, xenon, hexafluoride, xenon, tetrafluoride. Even we can take xenon, oxygen, tetrafluoride also we can write, or even we can take xenon, oxygen, difluoride. So what we come across where from all these, if you are going to consider, so even you take krypton difluoride. So xenon hexafluoride, xenon tetrafluoride, krypton difluoride, xenon oxygen tetrafluoride, xenon oxygen difluoride. Recently these are known, these noble gas compounds to it. Okay, so what we come across? Chemical inertness based on that octet rule is there, but noble gas elements of the krypton and xenon are making a compounds combining with oxygen and fluorine atom. This is also the limitations of which one we can say that is octet rule that we have to print down. The next one is, which is that one. It is very important to say here, which is that one means. See here, this theory, what we come across, does not account where for the geometry of the molecule. No explanation at all. Failure to explain. So, geometry of the molecule. What we come across? So geometry of the molecule not explained by the octet rule. So what we say here does not account for the geometry of the molecule. One more thing, it cannot explain the, it cannot, so it cannot explain regarding which one? The relative stability. This is very important. Relative stability of the molecules. Relative stability of the molecules. In terms of energy. In terms of energy, student. In terms of energy. So these are all the few limitations that will be come across. What I said now. So even it is forming which one? Inert gaseous molecule like xenon forming xenon oxygen difluoride, xenon oxygen tetrafluoride. So no explanation. So what we come across, it is failure also to explain the geometry of the molecule, shape of the molecules. So now, so I will stop at this stage. If you are having any questions related to today's concept, you can post where in your chat box. Thank you for today. So one of the student asked, why not it is possible to take a double bond between carbon and chlorine? You asked. Where you pause in gas student. COCl2. Wait, sorry, student. COCl2. Now let us see here. So I took central atom, less electronegative, no doubt, carbon. Here, okay, we will write all the electrons. 4 plus 6 plus 2 into 7. First count the number of valency cell electrons. 4 plus 6, 7 twos are 14. Add all these 24 electrons you have to arrange in such a way that each atom acquire octet configuration. Okay. Now, if I am going to take, which is that one, central atom, better I will write with red marker pen, more visible for you. Okay. That is carbon. This is, sorry, I will take chlorine. Yes, chlorine, oxygen atom. Now, how to write? Let us see here. First, form a single bond. Okay, single, single, single. Now, remaining number of lone pair of electrons you have to write. Let us see here. I'm taking where on this. Yes. Now, here I will write, student. Now count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Electrons I wrote. But this carbon atom, you see, this carbon atom, whether is it satisfied octet 1, 2, 3, 4, 5, 6 only. That means what I am making. Your question is, why not between these two? Why not between these two? Is it correct? No. If you are making a double bond, already chlorine atom, both these chlorine atom acquired octet configuration. 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. That means one electron, one pair, sorry, this pair of electron I will involve where in the multiple bonding, because oxygen it can form a double bond. Oxygen it can form a double bond. Are you following what I'm telling? That means if you want to see chlorine atom already acquired, how many now required? Only one electron is required. So to acquire 8 electronic configuration. Carbon already satisfied. Now, before it is not satisfied because only one electron pair I have been shown. Here 2 electron pair. Therefore, so if you are forming a double bond, so now 1, 2, 3, 4, 5, 6, 7, 8. Carbon is also happy. These two chlorine atoms are also happy. What about this oxygen? 1, 2, 3, 4, 5, 6, 7, 8. Now count. So here I wrote 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24. Like this, that one you have to remember. Okay? So thank you, student.
Okay, good evening. One of you asked regarding the valency of carbon. Already this molecule is here. So at the same time, you know, carbons, whatever the number of electrons, it is there. It has got 4 valence electrons. It has got 4 valence electrons. So you can indicate like this for carbon. These are the 4 valence electrons for carbon. Even in CH4 you take. Hydrogen also has one electron, 4 different hydrogens you take. It has got one valence electrons there, and this you are showing the bonding there between the carbon and hydrogen. So number of valence electrons for carbon, if you take, it is 4. Hydrogen has got 1 each. So total number of electrons after bonding with 4 different hydrogens for carbon, it shall be 8 electron, and it is stable. So valence electrons for carbon is 4.
One of the students asked, what are the rules that are followed while writing the Lewis structure? Again, I am repeating CA. First, you have to see if it is a neutral molecule. First step, count the total number of valency shell electrons. For this posing gas, I have been taken carbon valency shell electrons 4, oxygen 6, chlorine 2 are there, 7 2 is 14, 24 electrons. It is a neutral molecule, no charge. Suppose if it is possessing a negative charge, that charge is to be treated as an electron and a count. For example, if we are going to take now CO3 2 minus or NO2 minus, NO2 minus nitrite ion. This one you have to add -1. Correct? If it is a plus, we come across in the previous class like ammonium ion. After taking total valence shell electrons, subtract 1. That represents total number of valence shell electrons from that species. Okay, this is first step. Second step is, which is the central atom? 3 conditions you have to remember. That atom should be always less in number. Second criteria, it is less electronegative. Less electronegative. And one more thing in this, always hydrogen atom and fluorine atoms, they are not at the central. Always they are occupying terminal position. Fluorine atom and hydrogen atom. So that way you have to go through. Then third step, write a single bond. Represent a single bond. After writing skeletal structure, write a single bond. Show a single bond. Remaining all the lone pair electrons you have to write. Wherever the atom is not acquiring nearest noble gas configuration, if it is hydrogen, helium configuration you know, helium. Is it correct? No, it is understood. Rest of the elements, if you are going to consider all this, nearest noble, octet configuration. So whatever the lone pair of electrons are there that are utilized to form a multiple bond, that may be double bond or that may be triple bond. These are the few things. Again, we will go through, student. Thank you.
One of you asked, how can there be a molecule where the atom holds more than 4 bonds? See, one thing sir has told you already, the octet rule is not universal. It is not accepted. It is not applicable to all the molecules. 2 examples he had taken. One was PCl5. One was PCl5. PCl5. So here you know very well phosphorus has got 5 valence electrons. So those are involved in the bonding with the 5 different chlorine. So that's why the total number of electrons you count after bonding, it shall be 10 electrons. So this is an exception. This is an exception for the octet rule. Already it has been told octet rule is not universal. Octet rule is not applicable for all the molecules. There are some exceptions. Even the same thing it is for SF6. Okay, SF6 also you have the same thing. So in this also, sulfur, you know, it has got 6 valence electrons. So 6 bonds it is forming. The total number of electrons you count, the total number of electrons after having bonded, it is 12. So for this reason, it is going to be forming more than 4 bonds. So these are exceptions. These are exceptions. Okay. Thank you.